Hey everybody, we're back to finish our 8.4 notes. Yesterday we learned how to convert in between logs in exponential format. I'm actually going to use that today to kind of show you how some of this stuff is true. So hopefully it'll help out. And then again, after today, you should be able to do your 8.4 homework on your timeline there. Leave me a comment or whatever, I'll help you out, and then we'll get going. Okay. So in your guided notes, and remember, you can pause this at any time to write down stuff. You can just listen at first. But in your guided notes for 8.4, we kind of left off after example 8. And now we got to learn two properties. Well, they're pretty important properties, and they're going to be used for a lot of sections in the rest of the chapter. So make sure you're really following along and understanding where this might be used. So the first thing states the power property of logarithms, states that if you have a log, remember we say base and then we state the base, log base b of a to the x power. Well, if your argument has a power, it doesn't actually have to stay there. This is why logs are actually really important, and we're going to use to help them solve exponentials later on, is because the exponent piece does not have to stay an exponent. It's allowed to travel down in front and become just a regular size piece of multiply. So this actually becomes x times the logarithm, and we'll say log base b of a. Now again, so if the argument has an exponent, the exponent is allowed to come out in front as just a piece of multiply. That's called the power property. Now again, why is it called a power property? Is because x is a power inside a logarithm and it can come outside. Now the next one, and I'll show you, we'll be using this to kind of help us out again. And I'll use the converting to show that this is true here in a little bit. But log base b of b is equal to, well, the answer or solution is 1. Now, we can actually use our conversion to show that this is true. Because remember, if you have a log equation, in order to convert it to an exponential equation, you move the base. And if this is true, which again, I'm telling you it is, we can prove it's true by converting it to an exponent problem. Well, if we convert it to an exponent problem, you have to move the base. Well, the base is b. And if we move the base to the other side, it's no longer a log problem. So on the left side, the log would go away. The argument of b would still be on the left side. And then the right side is now an exponent problem. But remember, the exponent problem, the base of the exponent problem has to be the base of the logarithm. So b was the base of the log. When you move it over, b is the base of an exponent problem, and the right side is his exponent or power. And b equals b to the first is true. Now, I'll show you this. I won't show you in every single problem, but that is the reason why the rule is true. All right, so now your first two are just going to be basic, whether you actually know this second rule, and then you'll be done with them. If you know the rule, they both take about literally a couple seconds each. Whenever I see this logarithm for number 9, log base 5 of 5, I notice that the base of the logarithm and the argument of the logarithm are exactly the same. So that is going to be our equal base property. When the base equals the argument, our final solution is just 1. So since the base is 5 and the argument's 5, log base 5 of 5 is 1. That's our second rule that you learned today. Same thing here in number 10. It's log base 1/2 of 1/2. If the base and the argument are exactly the same, it reduces or simplifies to be 1. All right, so now what we're going to see though is every problem on the rest of your sheet, starting with number 11, will not be this simple. So we're actually going to have to bring in the power property of logarithms as well. So if we do number 11, we have a little bit of an issue. We have log base 7 of 49. Well, now our base and our argument are not the same. and the base is going to be locked in. We can't change that, but we're going to try to make the argument look like the base of 7. So this is very similar to how we did exponential equations. We wanted to make the bases the same in those problems. Well, now it's kind of the same thing. I want the 49 to be a 7. So you do have to know a lot of your power problems. And hopefully, as a little review, especially maybe even from middle school, we would have known that 49 is equal to 7 squared. And since they're equal, we can replace the 49 with 7 squared. So the argument, instead of 49, is now 7 to a power of 2. Remember, I'm not doing any math except for I'm just writing it as something that is equivalent. But right now I can't use that property. That property stated that the argument and the base had to be exactly the same. Well, 7 and 7 squared are not exactly the same, but that's why we learned the power property of logarithms. This exponent does not have to stay here. If you read the first rule that we took today in our notes, it says that that exponent is allowed to travel down and become a regular size piece of math. So using the power property of logarithms, I now have a new expression, and it's 2 times log base 7 of 7. Now the argument and the base match up. That's the argument, that's the base, and log base 7 of 7 is 1. So I have 2 times 1 is 2. We'll try another one of those. And then I'll show you how it could actually be converted into exponent problem in order to prove that it's true. So here will be number 12. So if you're looking along in your guided notes, or if you don't have your guided notes, you can simply write down the problems like I'm writing down. And remember, feel free at any time to pause it so you can write down the stuff. It's kind of better maybe if you just listen and watch at first, get through a problem, pause the video, and then write down all the steps. Okay, so same scenario that we just had in number 11. The base is 2 and the argument is 8. Well, we don't like that. So I have to keep log base 2. The base is locked in, never change the base, but the argument, we can rewrite it for something that is equivalent to it. And again, 8 is a power problem if you really think back. We should know that 8 is the same thing as 2 to a power of 3. 2 times 2 times 2 is 8, therefore they are equal. So instead of 8, I can write it as an exponent or power problem. Now I can use my power property of logarithms. And my power property of logarithms states that the power or the exponent does not have to stay in the argument. He can travel down in front as a piece of multiply. So my new problem is 3 times log base 2 of 2. Hopefully now the base and the argument match up. So log base 2 of 2 is 1. So I have 3 times 1 is a final answer of 3. Now what I'm going to do is, we know that log base 2 of 8 is equal to 3. I'm going to take away the work. So again, you can copy this down, but I'll show you that if you convert to an exponent problem, then it would look like it is true. And remember, what you start with and what you end with are equal. That's what we're doing. We're just simplifying it or writing it a little bit nicer. So if I take number 2 and I put the original problem and the answer right next to each other, it's going to be log base 2 of 8 is equal to 3. What we started with and our final answer. Well, if we convert it, and if you remember what we did yesterday, if you convert, you only move the base. So the base of the logarithm would move sides. Now when you do that, it's no longer a logarithm, so the log goes away, and the only thing on the left side is 8. And on the right side is now an exponent problem, and the base of the log is now the base of an exponent problem to this power. And when you look at that, it looks true. So I know my answer is correct. If you ever want to take your original problem and your answer, set it equal, and then convert to double check if you did it correct, you could. All right, let's try 13 and 14. There's going to be a couple of tricks here, a little bit harder. So let's see if we can get through these. Number 13, we have log base 6 of a fraction 1/36. Now, in order for this to kind of get the base and the argument to match up, I'll need to do about 2 steps. The first thing that I would want to do is not worry about the entire fraction, just worry about the denominator. 36 can be written as 6 if we know that 36 is 6 squared. Now the next thing that we have to be able to do is understand that while we've never done this before, we've always went from a negative exponent to a positive exponent, because that's what our Algebra 1 teacher taught us. If it's beneficial to us, we could make it a negative exponent because they are truly equal. So if we don't want that 6 to be on the bottom of the fraction, we can move him to the top, but his exponent would be negative. Now in the past, I've always heard that this is a little bit tricky, and the reason why is that you've never made negative exponents. You've always been forced to turn them into positive exponents. But if you look here, and you ask yourself, how would I make that positive? Well, you'd take the 6 to the negative 2 to the bottom, and then it would become a positive 2 power. You'll see that these are the same things. Now that I have this set up, I can use my power property, because I want the 6 to match up with the 6, but I don't want this negative 2 to be here. So the power property says the power can come outside as a multiple, and I have negative 2 times log base 6 of 6. And since the base and the argument match up, using your equal base property from above, we know that that is 1. So I have negative 2 times 1 is negative 2 is my final answer. Okay, last problem, number 14. This is a little stretch on people too, because we have to remember about fraction exponents here in just a second. So number 14, we have log base 100 of 10. Now the most common mistake that I see is people actually use 10 squared as 100. And while that is true, we can't use that because the base is locked in. We need 100. And we can't change the 10 using that, but we can use a version of it. If you know that 10 squared is equal to 100, well, we're trying to change the 10, and this equation doesn't have 10 by itself. But this equation has a sister equation, we'll call it, and you should know square roots then. You would know that if you square root, 10 would equal the square root of 100. So now, since the 100 is locked in, I know the 10 has to change, and we want to turn it into 100. This pops into my mind right here. So instead of 10, I can write the square root of 100. But it doesn't totally match up yet. I need the base and the argument to be exactly the same. 100 is not the same thing as square root of 100. But if I can take a radical and turn it into a rational exponent from our previous chapter, I would know that log base 100, the square root of 100 could turn into 100 to the 1/2 power. Now, remember where you get your fraction exponent. You get your fraction exponent from the numerator is the power of your radicand, and the denominator is the index of your radical. So that's 100 to the 1/2 power. Now, I'm so close. The 100 is the base. The argument is almost 100. I just need the 1/2 to move, and using the power property, the power can come down in front as a piece of multiply. So I have 1/2 times log base 100 of 100, and this equals 1. So I have 1/2 times 1 for a final answer of 1/2. I know that's small, but hopefully you heard me, and you guys can write down 1/2 as your final answer. All right, you guys, please make sure you do the homework on the timeline. Now you should be able to finish it. Tomorrow, I believe that we're just going to do some extra examples to help you guys out. Make sure you're really kind of like solidifying this information. Might have a little Google form for you to fill out to check for understanding. If you get some wrong, don't stress. It will not be graded for correctness, but it will be graded for just participation, and make sure that you're doing it. Remember that the biggest thing is we're trying to not stay stagnant. We're going to move. It's going to be a little bit slower than normal, but I'm here to help you guys out. Please make sure you're doing your stuff and let me know what I can help you with.